I'm Lieutenant Commander Kevin Doremus, a WP-3D Orion pilot and safety officer here at the NOAA Aircraft Operations Center in Lakeland, Florida. Looking forward to giving you a tour of our facility today. Welcome to the cockpit of Miss Piggy. This is a plane that was built in 1976. A lot of what you see in the cockpit is original to 1976, but a lot of it is also upgraded. As you can see, we've got some upgraded engine instruments, some upgraded displays up here. These planes are maintained really, really well by an extremely talented group of men and women in our maintenance and engineering department. Typical hurricane crew, we fly with 3 pilots, so there's 2 pilots flying, 1 pilot resting. We've got a rack in the back where you can take a little nap, even though napping in a hurricane sometimes isn't that easy. And we typically have 2 flight engineers as well. So again, 1 in the seat, 1 resting. A pretty interesting crew complement with the flight engineer. Nowadays, most planes don't have flight engineers, but they are a critical team member to this operation. Their kind of job is to basically monitor the health of the engines, and they're actually physically manipulating the power levers for us in the storm environment. And in the hurricane environment, it's really, really important for us to maintain a set airspeed. And that particular airspeed is 210 knots indicated on our airspeed indicator. There's one here, there'll be one on the screen here, and then there's another one over there. So we're looking at all 3, making sure we maintain 210 knots. So this is basically the gas pedal right here. More forward, more power, pull back a little bit slower. And the way that we fly it is really interesting. So the pilot in the left seat is what we call the pilot flying, the one that's physically manipulating the controls. They've got rudder pedals at your feet, and then the stick left, right, up and down. The pilot flying in the hurricane environment, the job is to maintain wings level, fly a track over ground that's assigned to us by the flight director or airflight meteorologist, and maintaining as best we can altitude. So as we're flying that track at that altitude and wings level, maintaining that course over ground, the flight engineer is manipulating the power levers to make 210 knots, and the pilot in the right seat is basically monitoring the whole operation, backing up the pilot flying, and handling all the communications with the flight director and the science crew in the back of the aircraft. Now, if you can imagine, in a hurricane environment, you get a lot of updrafts, a lot of downdrafts, strong headwinds, crosswinds, tailwinds. It's a very dynamic environment for flying. So we have to fly the airplane a little bit differently. When we are going through, typically the eye wall is where we get the highest concentration of turbulence and updrafts and downdrafts. We have to manipulate the airplane to maintain that 210 knots. When we are max power and the airplane is still slowing down, we can basically maneuver the airplane with a pitch down attitude, trading our altitude for airspeed. So the flight engineer will say, I've got max power. The guy in the right seat will say, we're still slowing down. So you take the stick and you push it forward a little bit, and you get a little bit of airspeed that way. Same thing in the reverse. If we are really fast and the power levers come to flight idle and our speed is still coming up, we'll take the stick and we'll pull it back a little bit. Again, trading that altitude for airspeed. Like I said, it's really important to maintain that 210 knots. If you go too fast, you can overstress the airplane. If you go too slow, you can stall the wing out, and then the plane will stop flying for a short amount of time. So it's very, very important that we maintain that airspeed. So very dynamic environment, requires a lot of communication, a lot of practice, a lot of utilizing what we call crew resource management, or CRM. We are managing a large team. We have the flight station up here, which is pretty small, but we've got a whole complement of people in the back: navigators, flight directors, visiting scientists, media, in-flight technicians, mechanics. Very, very interesting environment, but it's a lot of fun, and I fly with some of the best men and women in the world, and I think it's just one of the greatest jobs. And if you have any interest in ever flying for the NOAA Corps, being a pilot, go on our website, check out information about the NOAA Corps, and you can fly with us someday.
Hi, I'm Ashley Lundry. I'm a meteorologist, and I'm one of the flight directors that flies with the NOAA Hurricane Hunters. Right now I'm standing next to Miss Piggy. She is one of the P3s that flies right into the eye of a hurricane. So I have my degree in meteorology. I also have a master's degree in physical science. When I was little, I was really good at math and science. I loved math and science. I know a lot of people don't admit to that, but I also thought it would be really cool to be a meteorologist. I found out that there were people that flew into hurricanes, and that became my dream job. How cool is it to fly into a hurricane? I know a few people will think it's absolutely terrifying, but I think it's just an amazing opportunity. Let me go ahead and show you a couple of things about the plane. We have 3 radars. We have a nose radar, we have the lower fuselage radar, and we have the tail Doppler radar. So when we're flying, the nose radar is really the operational radar. It's the one that's keeping us safe. We can see right what is in front of us and make sure that we're not flying through anything that's too dangerous to fly through. The belly radar is kind of a combination of flight safety and then also research. So we are able to look at the big picture and also zoom in on the storm and use it with the nose radar to make sure we're flying through safe weather and that we don't need to go around something. But also after the storms, those radar files can be used for research. The third radar we have on the plane is the tail Doppler radar. It's on the tail of the plane, so it's not really helpful for safety of flight because we're not seeing anything on that radar until after we've already flown through it. But it's also a really useful radar operationally and for research. The tail Doppler radar points to the front and to the rear, and it's essentially painting a 3D picture of what the hurricane looks like, and that's being sent back, and the forecasters at the National Hurricane Center can get a better idea about what the storm's doing. That data also goes into the forecast models and helps improve the forecast accuracy on where a storm is going to go. Right now I'm standing in front of the SFMR, that stepped frequency microwave radiometer, and yes, that will be a Jeopardy question later. The SFMR is measuring the brightness temperature of the ocean's surface, and with algorithms, it is able to take that brightness temperature and give us an estimate of what the surface wind speeds are. So that data is getting sent back to the National Hurricane Center and letting the forecast know as we're flying over the storm how strong the winds are on the surface. Let's go ahead and head to the plane so I can show you inside. This is where I sit on the plane. This is the flight director station. We do have a window, which is nice because we actually do look out the window a lot to see what the conditions look like on the surface. It tells us a lot about what the winds are and what the structure of the storm looks like. In front of me is where the pilot, co-pilot, and flight engineers sit, and then across from me is where the navigators sit. So it's really great being across from the navigator and so close to the pilots because there's just a lot of coordination that goes on during the plane, and even though we're talking on headset, it's nice to be able to look over at the navigator and ask questions as we're making decisions about where we're going to go next and how we're going to accomplish the mission. The thing that's unique about this is it's not just one person that makes or breaks the mission. It really truly is a team to accomplish everything. So we fly both operational and research missions, and there's different types for both. With the operational missions, specifically during hurricane season, we can be tasked by the National Hurricane Center to fly investigative missions where we're flying low and there's really no storm that's developed yet, but the purpose of the mission is to see if there is circulation on the surface and if it's a closed system. We also, tasked by the National Hurricane Center, can fly fixed missions, and that's once a storm does have closed circulation. We're going out and we're hunting for the center of the storm. We're collecting data, the exact position of the storm, the winds, the max winds at flight level and at the surface, pressure, all sorts of meteorological information that we're putting into a message called the Vortex Data Message to send back to the forecasters at the National Hurricane Center.
So many people ask, how do you plan a flight into a hurricane? It's quite an intensive effort. It takes a lot of people to make a mission like this go off without a hitch. And it basically starts at the very beginning of the hurricane season when we get issued what's called our Hurricane Watch Bill. And that's essentially a pilot schedule, a crew schedule that's issued by your flight ops department here that says during the period of this date to this date, you are on call and you need to be ready to fly at a moment's notice. So when we see these storms coming and we're kind of, we look at the watch bill, see if we're on the list, we'll get that call and we'll say, hey, you are tasked to go fly let's just call it an 0400 fix. So that means we need to be at a specific point in the storm, usually the center of the storm, at 4 in the morning. And so that kind of sets off a whole bunch of different things. We kind of gather the team, and we congregate here at the NOAA Aircraft Operations Center in Lakeland, Florida. Our flight directors, which are our in-flight meteorologists, a very talented group of men and women that are extremely good at what they do, basically take a look at the information that's coming from the Hurricane Center. So depending on the kind of mission that we're going to support, it's going to change the way that we fly it. There are all sorts of different patterns that we can fly. Our standard, we call it reconnaissance pattern, is a rotated figure 4, where we basically, if the storm is spinning like this, we'll start at one point of the storm, we'll go through the eye, we'll go downwind, then we'll go through the eye, then we'll go downwind, then we'll go through the eye, we'll go downwind. And we'll do that basically as many times as we need to get the information for the scientists. So we find out what mission profile we're flying, the flight directors take a look at it, and they provide an exhaustive weather and mission brief for the entire crew. So we meet up usually about 2 hours before our scheduled takeoff time. We all get together in one room, and our flight directors will run through all the research priorities, what they want to do, what the storm is doing, where is the storm, what kind of conditions are we expecting. Like I said, very, very talented group of men and women that know their stuff really well. And us aviators up front really count on that brief to give us an idea of what we're going to expect. A typical pattern that would be issued to us would look like this coming from the Hurricane Center. So this was actually from Hurricane Dorian. Let's see, that was early September 4th. So this is right before it was about to make landfall in the Carolinas. And this is our standard reconnaissance rotated figure 4 pattern. And you can see, taking off out of Lakeland, this point number 1 here, we call that our IP, or initial point. That's basically where we are on altitude, on course, making our first pass through the eye of the storm. And each one of these points are where we're going to use drop zones, where we're going to drop those weather instruments that are measuring all sorts of different parameters from the aircraft all the way down to the surface. And there'll be individual drop points throughout based on the scientific need. We'll take this information, and our in-flight navigators, which sit right behind us in the flight station, take that information, they plug it into their computers, and they basically run the numbers. They say, okay, this is going to be a 10-hour flight, we're going to be 8 hours on station, and that's really important information for the scientists to be able to plan out how much time they have in the storm. They'll tell us transit times, it's going to take an hour and a half to get out to the storm, that kind of thing. So we take off out of Lakeland, and we'll usually drop a waypoint at our first initial point that we talked about. So in this case, it'd be right off of the east coast of Georgia down here. And we file what we call a WRA, or Weather Reconnaissance Area. It's a special, it's not a TFR, it's not special use airspace, but it's an agreement that we have with the FAA and also with the 53rd Weather Reconnaissance Squadron that fly the C-130 Hurricane Hunters. Basically blocks out the airspace for us so that we are able to maneuver as needed and deconflict our aircraft between the Air Force Hurricane Hunters, because many times we find each other in the storm at the same time. Sometimes they're leaving and we're going, or sometimes we're in there at the same time doing different research and reconnaissance profiles. So we get a block of airspace. That's really good because it allows us the flexibility to maneuver as needed. Usually we don't run into any other airplanes in the hurricane environment. If we do, I hope it's not one of you. But we usually have the airspace to ourselves. We do stay in constant communication with air traffic control at all times, either via satellite communication, or our navigators can talk using HF, high frequency radio communications. And then when we're closer to shore on a mission like this particular one in Dorian, we're close to shore, we can actually talk to controllers on local VHF comms up in the flight station. But yeah, we'll file a flight plan just like any other flight. We will fill out our crew manifest, which is basically saying these are all the individuals that we have on board. So if something were to go wrong, they know who is on board. And we'll make phone calls to the controlling agencies a lot of times, let them know, hey, we're coming. A lot of times we'll have to go through different countries. Our flight operations department does a really good job at the beginning of the season making those arrangements to have overflight clearances in place, and also landing clearances, because a lot of times we'll deploy to different locations such as Barbados or the U.S. Virgin Islands, Bermuda. Basically when the storms are really far away and it's really important for us to get out there, instead of taking all of our gas to get there, we'll go ahead of the storm, land, get gas, and then be able to do a max duration flight from one of our forward operating bases in Central and South America. That's pretty much it. Like I said, it's a really exhaustive effort that takes a lot of people. And I feel very fortunate to work with a very talented group of men and women. learn something new every flight, and it's definitely an exciting mission. So thanks for following along, and contact us if you have any questions.